Okay, good afternoon, everybody. My name is Kishore, and I'm from A10 Networks. I'm here to explain about some of the problems that we solved in bundling our software into various environment using Kubernetes. There are a few esteemed speakers ahead of me who talked about Helm and how to deploy applications and different configurations and all that. We are kind of giving a view from a different side, where we have taken an application and deployed in a constrained environment, which is typically not the case when you deploy Kubernetes applications in an enterprise. Like you have a cloud, we have infinite resources and all that. So before we go into the problem statement, let me just, because they sponsored my trip here, I want to plug in my company. A10 Networks is a company based out of San Jose, US. They do network services, like firewalls and application delivery controllers and CGN. So it's a high throughput network software. So we deploy that as a SaaS, as well as software, as well as an appliance. So we actually package the whole software as well as a management platform. Though here it's what I'm talking about, my application is a management platform, and it has a constraints in sense it needs to support both public clouds, private clouds, bare metal, SaaS model, an enterprise model. It needs to support a humongous throughput. The application has to support million requests per second because they're all network devices sitting on the edge. So when I'm upgrading the application, it has to be available all the time. Then there are various restrictions in terms of the market requirements. Similarly, in the platform we designed almost a year and a half back, when the Kubernetes is in the very early stages, based on Kubernetes, the whole microservices, there are 20 plus containers we ship, and there are a few stateful objects. Like any other enterprise management platform, you need to have those things. And that's where the problem comes into picture for us. So the constrained environment that we talk about here for our application is that one product has to run in all models. So I can't design a product that runs on hardware and a separate product that runs as a SaaS. Similarly, I need to have high availability like the Kubernetes supports, scalability like a microservice architecture supports, even in a constrained environment. And I have to run this application on appliance. That is, I have limited amount of CPU and memory. That is, I have 20 CPU, 128 GB. I need to be able to upgrade the software without bringing down availability within the same CPUs and memory limitation. Then I only have local storage. I don't have a shared SAN. I don't have a common platform that I can ship it, or I don't have NFS, because that will create a lot of complexity in the application. And it has to work both online as well as offline, because our software is heavily used in telcos where they don't allow internet access and other things, right? So again, the approach that we are saying, again, I've taken a lot of problems there, but I'm taking one simple problem that we tried to solve, and I'm going to explain that, which is stateless. You're not worried about, you just upgrade them, you bring down the system, as long as the hardware is available, CPU, then you bring in the other system, it works fine. Stateless is where the problem. So we had to take a configuration where we have replicas, and where we don't have replicas, we have to take sharding. So that's the two methodologies, and then use the persistent volume as a local storage. So whenever you bring down one node and you do a rolling upgrade, basically bring down one node, make sure that the persistent volumes and local storage class combined brings to the application onto the same node, so the data is not lost. So that's the most important thing. And the fourth one is the Kubernetes kubeproxy, which is the Kubernetes gives, and the load balancers, which will help us, internal load balancer, which help us direct the traffic to the node that is active. So the availability is always gathered. So this application basically has a very network management platform that has to be available all the time. And this is one of the problems that we solved is the stateful objects and how to upgrade them in a complicated fashion. So this is the JSON that looks like when you are upgrading these stateful objects in a constrained environment. Okay, thank you. I'll ask you for any questions.